Here we are removing the batteries, which are two batteries, two 12-volt batteries from our engine. Um, Basically, we're trying to show that we do not need the batteries once the engine is running. The engine will produce its own energy and can run without any input from any outside source whatsoever. And this is one of the reasons we're doing this. Move the batteries out. Down there you can see a little pedal. We can use that as a like a pedal in your car, and you can adjust the timing sequence and the RPMs. Or we also have a hand rheostat where we can adjust the timing sequence of the engine, either fast or real slow. And here Joe is going to increase, and he can decrease the RPMs with a hand rheostat. The engine here right now is doing about 700 RPMs. It's a two-cylinder engine, 400 horsepower, and we can produce approximately 350 kilowatt per hour by attaching a gearbox and a generator to it. This is a small engine. We can do 4, 6, 8-cylinder engines up to a megawatt if we want. We have it on a frame, bolted to a frame. There's a dyno. We're going to do a test with a dynamometer to show the power of the engine. Put a load on it without the batteries connected. Just the engine producing its own energy, its own power. And this runs just like a regular car engine, just has a key, push button. You can turn it on, turn it off. We'll show you that we can turn the engine off when we start it up again, just like you would your regular car. There's a generator up there, and we have a belt. And on the side you see those long things are resistors. Because we produce so much energy, we have to dissipate about 300 amperes. And here we're going to drop the RPMs real low. The engine will not shake, throw a rod. Very solid, very smooth running at any RPMs. So it's doing about 75 there. And then he'll increase it again. The engine is made to run at about 400, 500 RPM. And then if we need more RPMs, we can put a gearbox on there and increase the RPM to whatever we want. If we're running, instead of a dynamometer, we can run a generator. And here the RPMs are going to go real low. There they are. Might be 50 RPM. Still the engine runs. Doesn't shake. Doesn't quiver. Now we shut it off, so we can show you we shut it off. Now we're showing the dynamometer readout, and we're at 123 RPMs, 120 RPMs, with 276 foot-pounds of torque being applied to the engine. The engine is running, as you can see, at 120 RPMs, real smooth. And we're going to put a very heavy load on it, up to 500 foot-pounds. We're going to try to go here we went as low as 112 RPMs, and we didn't want to go any lower than that because we didn't want to harm the engine, which is the only one we had. So 112 was about as low as we could get. It was a very heavy tractor type hydraulic dynamometer. And there you can see our engine running steady at about 120 RPM. There's a coupler to the flywheel. And you can see that it's a very heavy coupler. And the engine, like I say, is very powerful. It can run at any RPMs and will not quiver or shake. It runs real smooth. You can see how heavy the dyno is. It's run hydraulically cooled with water also. The engine runs at about 130 degrees Fahrenheit. 140, it got to 140 sometimes. There's a battery still disconnected. We have no cooling system in the engine. The engine does not require a cooling system. As I mentioned, it stays at about 140 when you're putting a load on it. So that's, you can touch it. It's not very hot. Actually, it's quite about lukewarm. There's your dyno. The dyno has its own batteries. And then we'll see what the readout is, and we will adjust the RPMs and increase the torque, or we can increase the RPMs and drop the torque. There's 116 now RPMs and 278 foot-pounds of torque. We can run this engine at about 100 horse and 100 horsepower at these low RPMs. And like I say, the maximum horsepower of the engine is 400. We're running slow, so we just want to do a test here. See how now we've got 519, 520 RPMs. There's your reserve foot-pounds of torque on the right, the other readout on the right, which means we can add another 400 foot-pounds of torque. So basically about 1,000 foot-pounds of torque is what this engine can withstand. And as I say, the lowest we would run it on a load is about 112. There it is, 113. 112 with 500 foot-pounds of torque. That's the best that we wanted to do. And we're only showing 11 horsepower over here to your right, the top right one. We've got 294 foot-pounds of torque in reserve. And then we'll increase and adjust any way we want. Increase the horses, increase the RPMs, drop the RPMs, increase the foot-pounds of torque. And we'll show you on this readout. Now we're running real fast. Well, not real fast, but about 700 RPMs. The torque is always basically the same regardless of your horsepower, so we don't have to run our engine faster than 400 or 500 RPMs. 700 would be a good speed for the engine. And there you are, 716 RPMs and 770 foot-pounds of torque, 105 horsepower. Actually, the dynamometer got hot on us, but the engine did not.
What is the speed that you're running now? Running at 1,200 RPM now. How low a speed can you control? 500. And 560 on the